Hi everyone, this is Poornima Mahalingam. Welcome to the video lecture series 2 of electrical machines and drives. In this video lecture series, today we are going to discuss about synchronous motor. Before going to synchronous motor, previously we have discussed what is the review of DC motor and induction motor, single phase induction motor and a three-phase induction motor. In this topic, we are going to discuss about synchronous motor. Come, let's go to the video. What is synchronous motor? Synchronous motor, a motor short of synchronous electrical motor. Okay. A synchronous motor is a sort of synchronous electrical motor is an AC motor where the rotation of a rotor or shaft is synchronized with the frequency of the supply. Where the rotation of the rotor is synchronized with the frequency of the supply. That is the rotating period of a rotor is equal to the rotating speed of a machine inside. So the rotating period of a rotor must be equal to the rotating field of a machine. That's why it is synchronizing the speed with the rotor and the machine is not a synchronous motor. Okay. So here the common three-phase motor is a synchronous. There are most common type of three-phase motor is a synchronous motor and induction motor. When three-phase electric conductors are placed in certain geometrical position, that is in a certain angle from one each other, an electric field is generated, that is an angle of 120 degree for three phase, and the rotating magnetic field in a certain period, what happens is at a certain speed is known as synchronous. The rotating magnetic field at a certain speed is known as a synchronous speed. If if an electromagnet is present in the rotating magnetic field, the electromagnet is mechanically locked with the rotating magnetic field and they rotate at the same speed as the rotating field. Here the magnetic locking is very, very important. Now coming to synchronous, where is the term synchronous motor comes from? As the speed of rotor of a motor is the same as the rotating of the magnetic field. So the rotor of a motor and speed of a rotor of a motor and rotating magnetic field. If the fixed speed motor, because it is only one speed, whereas the synchronous, where in synchronous speed, the speed is synchronized with the supply frequency, and the synchronous speed is given by NS equal to 120 F by 5. 120 is F is equal to frequency, P is equal to number of poles. Okay. Here coming to the construction of synchronous motor. This is a construction of synchronous motor. We know the stator and three-phase supply, rotor, and we are having DC supply. And usually its construct is almost similar to the three-phase induction motor. And expect the fact that with the supply, we DC to the rotor. Here, what is the difference is we are supplying DC to the rotor. There is a difference. The main features of a synchronous motor is the synchronous motor in India not self-starting. The synchronous motor is most important is it is not a self-starting motors. They require some external means to bring their speed close to the synchronous speed before they are synchronized. So here we have to make the speed with the synchronous speed, and the speed of operation of synchronism is with the supply and frequency. Hence it is constant supply frequency. They behaves as a constant speed motor. Here the motors are unique characters of operating under any electric power factor. This brings the electric motor power factor improvement. Here the principle of operation. Here we can see the principle of operations. What happens? Here the rotor direction with north NS, SS, and we have seen the direction of clockwise and a double exciting machines. The two inputs provide the stator winding connected with the phase and DC of the rotor, and the three-phase induction motor carry three-phase current, produce a three-phase rotating magnetic field, and the stator has made with the same polarity NN and or SS with the same polarity. We can see the NN, NS will cause an attractive force. Why it is a, if same pole, what happens? It repels. If an opposite pole gets attract, so it is have with it's rotating with the same pole. If attracts, what happens? Here the magnetic locking will happen. So at having the same poles. This is what a method of starting here. We have so many methods with an external prime movers and the damper winding. In this case, we have so many methods. A synchronous motor find an application where the operating speed is less than around 500 RPM and high power required. For power requirement from 35 kilowatt to 2500 kilowatt, the size, weight, and the cost of corresponding three-phase induction motors are very high, and hence this is preferably used. Example, reciprocating pump, compressor, rolling mills, etc. Here comes the mechanical characteristics. Here we can the constant speed motor, the synchronous speed when the torque is maximum. So when the torque is maximum, the speed is constant. From the starting from the torque minimum to maximum, speed remains constant. That is what the synchronous speed. Synchronous speed. The speed is remaining constant with the help of maximum torque. So speed torque character of synchronous motor. Here come with a small video synchronous motor. Synchronous motor is capable of running constant speed. For high power applications, mainly used in high power application. Here, the rotating magnetic field is a constant magnetic field. Rotating. So, stator rotating magnetic field, rotor is a constant magnetic field. So, we have three-phase AC supply. We can see three-phase. So, it rotates in synchronous speed. So, rotating this stator is rotating synchronous speed. So, rotor is excited by a DC power supplies. It acts like a permanent magnet. This is also made as a permanent magnet and rotor stator. So the motor is synchronizing. Stator field is synchronized with the rotor speed. Here we can see. The slowdown version of magnetic field. You can see the speed, how it is turns, north pole, south pole, opposite poles, rotor, track each other. So we can see the opposite poles. Here the poles are opposite. Frequency, synchronous motor. So here the zero initial rotation. Here what happens? Since the rotor has got some inertia, so that fact, rotor won't be able to start. Here the damper winding. So giving initial rotation, the damping. Here we can see the electricity, how it is rotating. When the rotor has achieved, as the name suggests, synchronous motors are capable of maximum speed or rotating at how it is rotating. Synchronous speed, how it is rotating. Here we can see the final output. Torque level is more. So out of synchronism, the motor is overloaded and low power supplies and low excitation voltage. These are all some of the drawbacks. Same construction of synchronous motors also helps in improving overall power factor of the system. It improves the power factor of the systems. Thank you. Thank you. Today we have seen the overview of synchronous motor. With another topic we can see in next class. Thank you. Thank you so much.